Thanks for taking the time today to join the webinar. Today's topic is migrating and modernizing network-attached storage in AWS. I'm Chandra Reddy at AWS, and I'm a storage and data lake specialist. I work out of Austin, Texas. I'm also joined with my two storage partners, Alan Henderson and Tom Husick, who are AWS storage specialists, and they work out of our Chicago area. So this is actually a series of lunch and learn webinars. Today we are on the second topic, migrating on-premises NAS to AWS storage. Last week we did hybrid cloud backup using AWS storage. The recording is already up in the this URL, and if you for some reason were not able to join that, feel free to go back to this URL and register and watch the video. We have 3 more coming up in these next few weeks, one on June 23rd, 14th, and 21st. I'll encourage you to register to those webinars as well. And at the end of the meeting, I will share this slide deck with you so that you have all these URLs handy. Okay. So the agenda for today is what network attached storage, why is it so important, and what are the typical challenges that we have seen our customers face in their data centers, and how does AWS solve those challenges with its own offerings of file storage services among Elastic File System, FSx for Windows File Server, and AWS Storage Gateway. And towards the end, I will also share a couple of excellent blogs that our engineering team have written on our website, and I have kind of collated some of the important blogs for you all on these various topics to make it easy for you. So let's actually start with some fundamentals. What are the various types of storage? I think we are all familiar with this block storage, right? It could be direct attached storage or storage area networks. Typical protocols that are used is SCSI protocol to access the block storage. Could be over fiber channel, could be over IP networks, but the key protocol is SCSI. So that's block storage. The next one is a scale out object storage, like Amazon S3 as an example, right? So here there's like thousands and thousands of servers and storage that's accessible via HTTP. It's almost infinite storage, and you access it via HTTP protocol. And today's focus is actually on file storage, and file storage is typically accessed either via SMB from Windows workloads or NFS via Linux workloads. So we'll dive deep on file storage, also known as network attached storage in data centers. So let's start with actually the use cases, like why is file storage needed? So typically, enterprises have been using network attached storage or file storage when they have to create, share, and access data simultaneously with latency that is much smaller than an object storage. So some of the use cases are in the medical vertical industry, X-rays, MRI, CT scans are stored in the file storage so that access and can be accessed simultaneously by many users. Call recordings is another great example where millions and millions of calls are stored in a network attached storage and can be accessed by applications and users simultaneously. Media and entertainment is a very, very popular vertical where the network attached storage is very prevalent. And surveillance video cameras, etc. NAS, again, is a great dump yard for lots and lots of videos and photos. And again, more importantly, multiple applications and users can access the data simultaneously from a network attached storage. So those are the typical use cases. So it's very popular, and as you can see from this IDC storage report of 2019, 76 exabytes of network attached storage was consumed globally in that specific year of 2019. And many of these customers actually have pretty severe challenges when they're trying to self-manage the network attached storage in their data centers. The number one, the biggest one is expensive hardware refresh. Time and again, with so many customer discussions, what we have realized is that if they are buying, for example, a petabyte of network attached storage, spending millions of dollars on it, generally by the time they actually they format their drives and the actual usable storage comes down to like 700 terabytes or 600 terabytes out of the 1 petabyte. And then once you start carving out storage for various department groups and stuff, typically the usage is actually around 50% of the actual storage that they purchase. But not only that, they need backups for this network attached storage. So now they need to invest in backup infrastructure. They need disaster recovery. So now they need to replicate to another network attached storage in a second data center. All of this adds up: bandwidth cost, space, power, operational burden. That's what is the challenge with not only the hardware refresh, but also the administrative overhead that it brings in. And of course, this network attached storage is in on-premises, right? So, and many customers want to actually monetize the data by taking this data and marrying it with, for example, analytics services, AI/ML services. And in on-premises data centers, you just don't get that rich set of analytics and AI/ML services. And even if you do, there's a huge operational burden in managing them. And that's what slows down the innovation. So customers want to actually take their network attached storage or file data and store it in a cloud so that they can actually use this data with these enhanced analytics and AI/ML services. And it's not easy to scale this storage out. You have to buy it in chunks of, let's say, 100 terabytes or 500 terabytes or even petabytes. And all of this adds up, not only with respect to cost, but administrative overhead too. So AWS has very rich solutions that can actually solve all these problems. The file storage that's available in AWS come in the form of Elastic File System, also called as EFS, Amazon FSx for Windows File Server, and AWS Storage Gateway. And today we are going to dive deep into all three of them. And actually, Alan is going to demonstrate at a high level how to use this, how to create these file systems and use these file systems. So let's start with Amazon Elastic File System, EFS. Tens of thousands of customers have already trusted in Amazon EFS. They use this to store their file data and access this file data from many different services in AWS. So we'll talk about that. So typically, the journey of all those tens of thousands of customers have been that they have been using their Linux applications with using some NAS storage on premises. And what they have done is using solutions such as AWS Data Sync or any of the third-party vendors, for example, Comprise comes to my mind, they can migrate this NAS storage from on premises into AWS. So migration part is pretty straightforward. They take the NAS storage, put it in Amazon Elastic File System. They take their Linux applications and start running them in EC2. And some of our customers also run them in VMware Cloud on AWS and access the data from the Elastic File System, right? So this is a straightforward migration journey. But many of our customers, after the initial migration, they've actually modernized their applications. For example, containerize their application to access the Elastic File System. They have written serverless Lambda functions that can, again, store and access the data in Elastic File System. They have used AI/ML services like SageMaker to access the data in Elastic File System. So the important point that I'm trying to highlight here is that think of EFS not just as a data repository, but it has its deep integration with all these various services in AWS so that you can monetize on the data that you're storing in EFS, right? So it's not just a storage repository, but it's deeply integrated with all these services. And that's where the richness comes out. So that's at a very high level is what these tens of thousands of customers have been doing in migrating and modernizing the data. So what is EFS? How does it work? So it's highly durable and available. The data is typically scattered in 3 availability zones, right? So as you can see here, and then it's also designed for 11 nines of durability and 4 nines of availability. So that's Elastic File System. And on top of this, you could also do backup of EFS into an S3 bucket and also lifecycle it to a colder tier and reduce your costs further. So this is EFS standard, Elastic File System standard. Many of our customers have also shared with us that storing Elastic File System in 3 availability zones is an overkill for some of their use cases. So for that reason, a few months ago, we also released EFS 1 zone, which actually keeps the data in just 1 availability zone. The beauty of this feature, though, is that you still get 11 nines of durability. So from a data loss standpoint, you still have the peace of mind that this is as durable as storing the data in 3 availability zones. However, there is 1 less 9 of availability in EFS 1 zone. So, and of course, this can also be backed up using the integration that we have with AWS native backup solution. So we talked about EFS standard, we talked about EFS 1 zone to reduce your cost. Typically, you can reduce your cost by 47% by using EFS 1 zone. So that automatically brings us to the next topic of how do you optimize costs with automatic lifecycle management. So if you think about EFS 1 zone, the effective cost is $43 per terabyte month, right? So I'm giving you a ballpark estimate of $43 per terabyte month. And EFS 1 zone, the way, there are 2 storage tiers, EFS 1 zone and EFS 1 zone infrequently accessed. So the data lands in EFS 1 zone first, and then based on access patterns, the least access files, then they go into migrate into EFS 1 zone IA. So the combination of this, assuming that 80% of the files are actually not accessed frequently and hence they are stored in EFS 1 zone IA, gives you an effective price point of $43 per terabyte month. Okay. So this was 1 zone, and then similarly for EFS standard as well. It comes out to be approximately 8 cents per gigabit month, or ballpark $80 per terabyte month. Same concept applies. The assumption here is that 80% of the data is not accessed and hence lands in automatically tiers to EFS standard infrequently accessed. So that's like a ballpark estimate of costs. At this point, I think we will switch to a short demo. And Alan, I'm going to stop sharing so that you can take control of the screen and get to your demo.
Okay, Chandra, can you hear me okay?
Yes, I can hear you.
All right, and I've shared out my second monitor here with my connection to my demo environment. Just like to see if you can confirm seeing me in the Amazon Elastic file system.
Yep, we can see the screen, and I will encourage the audience to ask questions if they have any so far in the chat window while Alan is going to start the demo.
Perfect, yes. So good to meet everybody today. I'm Alan Henderson, storage solution architect at AWS, based outside of the Chicago metro area. And in 5 minutes, I want to try and at least give an introduction to EFS that Chandra has covered. So within the console, I am actually in the EFS service, where I do have a couple of, at least one file system already created. But just to show you the options and the ease of what it looks like to create one, I will actually show what that looks like by creating a file system where I would give it a name, EFS02, to match my naming convention. I would place it in a virtual private cloud, the actual networking component that I've already got configured. And this is the first of those two choices, decision points like Chandra explained related to, is it going to be a regional across at least 3 availability zones or a single 1 zone EFS deployment? So I'll leave it at regional and hit customize just to see the additional options that can be configured related to automatic backups. The lifecycle management that Chandra talked about, being able to, default is 30 days, but you can get as aggressive as 7 or up to 90 days. And then the performance between general purpose and max IO, or bursting, throughput, or provisioned. And the rule of thumb is start with general purpose, start with bursting, test your applications, test your profiles, and if need be, talk to somebody, like myself at AWS on the storage side, and possibly we could look at recommending, what sort of performance may be required to meet your needs. And at the very end, you would go to next and create this, but I'm just going to cancel and just show the file system that I already have running. Inside of this, you can see that some of those settings were still configured as I was just showing you. Towards the bottom here, you have multiple tabs to go through to look at various options. The one I want to point out here is network availability, because my VPC, my virtual private cloud, I have set this up across multiple availability zones. So I've also made sure that I have access to my EFS file system within each of the availability zones that I'm running in. And so I was pointing that out as one of the feature sets. I could spend an hour just going into all the feature sets here. But let's have a look at what that looks like from my 2 Linux machines that I have up and running. And you can sort of see the source IP addresses of these particular Linux machines. And these are the AWS Linux that I'm running. And so if you do a DFH, you'll better see that I'm mounted. You can see that IP address matches my availability zone 2B. And if I do the same here, you'll see that this is 1.254, which is the other IP address. So again, two network access points to exactly the same file system. And right now I am mounted into my EFS and have just a couple of files here that I have prepared for this to just show that when I'm on one of these clients and I go and create a file, and I'm going to do version 2 of a file for today's date. Just touch that. And on this side, I'll be able to see that this is shared storage, that both of these Linux-based clients are seeing the same persistent storage. So if this was containerized or even our Lambda serverless compute, this could be persistent storage that multiple of these compute instances can share and allow them to be more stateless, where the statefulness is coming from the shared file system that they all have access to. So in my 5 minutes, hopefully I was able to show you at least the one use case of EFS shared file storage within AWS.
That was perfect, Alan. Thank you so much. Feel free to ask questions in the chat window, please, and we'll move on with the presentation before we go back to Alan for the next demo. So just to summarize on EFS, it's really multiple availability zones, 11 nines of durability, pay as you go. You can grow and shrink the storage. You don't have to buy in chunks of 200 terabytes or petabytes. As your application grows, you can consume more storage, and then you can shrink that storage. When you delete files, you can share the data not only between EC2, but containers, Lambda functions, SageMaker, and also VMware on AWS Cloud. So with that, we'll move on to the next file storage service available in AWS, which is Amazon FSx for Windows File Server. So again, tens of thousands of customers are using Amazon FSx already, and their migration path looks something like this. They were using Windows applications, using NAS storage on premises, using AWS Data Sync or any of the third-party products. They migrated their NAS storage into Amazon FSx for Windows, and they migrated their applications into EC2. In many situations, they modernized their application using containers. And of course, if they have VMware virtual machines that they migrated to VMware Cloud on AWS, all these entities can access the shared data that is stored on Amazon FSx for Windows. There are some more use cases around SQL clusters that I will mention in a few minutes. But the important thing is that, let me get to the next slide. The important thing is that the files here are being shared across multiple applications and even users. So for Windows shares, this is a perfect solution. We recently announced a new product named Amazon FSx File Gateway. So in your data center, if you have lots and lots of users, hundreds of users using storing data and sharing data via network attached storage, you actually can replace that multi-terabytes or petabytes of network attached storage with an Amazon FSx File Gateway. What this does is it gives you a low latency access to your file data. So it caches the hot data, but in the background, it stores the rest of the data in FSx for Windows File Server. So for your users internally, it seems as if the data is actually resident in your data center and the hot cached data is resident, but the majority, the bulk of the data is actually stored in AWS Cloud, in AWS FSx for Windows File Server. And as I mentioned in the previous slide, this data is also accessible to other services in AWS, right? So this is a great solution if you have lots and lots of home directories in your data center. And of course, you can have site-to-site VPN or a direct connect pipe between your data center and AWS Cloud. Another important use case, which is very popular for FSx for Windows File Server, is that if you have Microsoft SQL clusters in your data center and you're thinking of migrating to AWS, you have choices. Obviously, the best choice is to actually modernize it by using an RDS service. If that's not the path right now and you would rather manage your SQL cluster, then you have two options. You can use Elastic Block Storage in AWS, or you can use FSx for Windows. The benefit of using FSx for Windows is that you don't have to pay Microsoft for SQL enterprise licenses. You just have to pay for SQL standard licenses if you choose to use FSx for Windows in your SQL cluster environment. So both your database files and log files can be stored on FSx for Windows. And of course, your clusters, compute servers can be stored in multiple availability zones. So that way you have the high availability as well. Okay, so the deployment options are FSx is available as a single AZ as well as multi-AZ. And if it's in multi-AZ, obviously the data is replicated across multiple availability zones, and it automatically fails over across AZs as well. From a cost standpoint, since this is FSx for Windows leverages native Windows deduplication, there's significant savings actually on the file shares. So assuming around 50 to 60% of deduplication on the data that is stored, this is how the costs look like. You have two tiers of storage that you could use, SSD or HDD, and these are the costs for single AZ and multi-AZ, assuming 50 to 60% deduplication. So pretty inexpensive. It's all in the box. It's fully managed by AWS. You don't have to manage compute and storage. It's all packaged for you for simplicity. So with that, I would like to pass it back to Alan for a short demo. So let me stop sharing so that, Alan, you should have control now.
Okay, just getting to the correct screen and bringing up my lab environment again. Hopefully you can confirm you can hear me, and I'm showing the Amazon FSx in the console.
Yep, we can see it.
Great, great. So now looking at our FSx file system to show how those are created. I do have a couple already created, but again, wanted to show the ease of starting it. We're going to focus on FSx for Windows file server. This is a Windows native as a service solution from AWS. So what does that mean? This is actually Windows technology that is running in the background. It's not an emulation like many NAS do and do very well. This is a native Windows file system, and we would want to give it a particular name, FSx 03. This is where you would choose that. Do I want to run in a multi-AZ for more durability or a single AZ? What type of disk would I want to provision? SSD or HDD. The size of the file system that would be created. Here we would get into which parts of the network, again, based on your networking, your virtual private cloud networking that you have implemented. You would choose specific locations for this to be deployed in, including which subnet it would reside in. I do have my environment set up in that good practice of public subnets and private subnets. Something like this would be typically deployed within a private subnet. And it wants to make sure that I just use the other private subnet as the not the same one. I'm selecting the same one every time. Sorry. There we go. So again, stretching the across multiple availability zones on the private subnets that I have created. It would want to join Active Directory. This is a Windows-based file system, so Active Directory. I have an AWS managed Active Directory deployed, but you could also use your own self-managed Active Directory. So if I did drop this list down, you would see my very creatively named demo.lab as my Active Directory. Encryption, additional settings, and you will be able to go ahead and next and create that. It does take a couple of moments to create. So what I'm going to do is actually go back and show you my current one that I have already deployed. And you can see I have a number of them deployed between multi-availability zone and single availability zone. The one I'm going to focus on is my FSx1, where again you can see some of the settings that I spoke about selected during creation time. The name, the sort of Windows UNC path name is being shown here. So I'm going to bring that up in a couple of moments to actually show you what this looks like. We also support actually DNS aliasing that. And that's something that's very common, especially with customers that have had maybe many iterations of Windows servers to NAS, to bigger NAS, and their applications are tied to a specific DNS name that started 10, 15, 20 years ago. So we can help ensure that we support that inside of AWS by enabling the DNS alias. So with that, let's go and have a look at what this looks like. So I've got a couple of windows ready here. So here is my UNC path. Let me minimize that. The white and white doesn't show through very well. So here is my UNC path. So there is that name that I showed, the Windows server name that I'm connected to. The default share is share, but others can be created. I've got for my Northern Virginia, Ohio, Oregon as potential other shares in my environment. But as I look at here, I've got a department share where we support things like previous versions as well. So just to show the previous versions are available here, where you can go back using your Windows, the VSS enablement that we support, to better go and allow users to do self-restores. I want to go back to a file that maybe was updated back in April based on what my lab is at the moment, and something's happened today where the file was deleted and I want to go back to it. I'll also show you the filer name view of that. So this is that same view, just through the filer1.demo.lab and seeing the same file system. One additional feature, and there was a chat question about this, was our support of the FSx File Gateway, which I do have deployed here. And I just want to bring up yes, this is my FSx File Gateway that is deployed in a different subnet. It's actually a different region. You can see that I'm in 10.2 here in Ohio, and this is actually deployed in 10.1, which is Oregon in my environment, where I can go in and actually look at that same file share from that remote office with the local FSx File Gateway deployed. Go in and here, go and create new files. So let's go and do just a text file. Webinar test file.txt, and as that's created, you will actually see that showed up in the region, the FSx file system that is behind the FSx gateway. So I'm going to stop and possibly hand back to Chandra if there's no specific questions on what I've just shown you.
That was great. That was a good demo, Alan. Thank you. There were a few questions that I already responded in the chat window. Let me share my screen. And just to summarize what we discussed on FSx for Windows, right? So you do not have to manage file servers by managing compute and assigning EBS storage and managing capacity management and then creating network shares and mounting them. So all of that, you can take away that operational burden and use FSx for Windows. It's a fully managed service from AWS. You can also back it up, obviously. You can take snapshots of it. You can reduce your Microsoft SQL license costs in a situation where you decide not to use RDS, but you want to manage your SQL clusters. You use FSx for Windows as the storage repository for your SQL clusters. And of course, if you have lots and lots of home directories, and as Alan just demonstrated, you can leverage FSx for Windows in the background, but you can also use FSx File Gateway to expose those home directories and network shares in your data center. So with that, let's move on to the next topic, AWS Storage Gateway. Why would you need this, and what are the different flavors? I'll cover that in a few seconds, but important thing to note is, so far what we have seen is EFS and FSx. You have many of our customers have decided to migrate their NAS storage to AWS. That's where they decide, okay, I'm going to use EFS for these workloads, FSx for these workloads. But there are situations where customers might not be able to migrate their application to AWS because of many reasons. They have, for example, a video capturing device from multiple locations, and they want to store the data somewhere, not in their data center, but in AWS. So that's one example where the storage gateway would make sense. Another example is, you already made an investment in your compute in your data center, and you want to, extract everything out of your investment by running your applications in that compute environment. But you do not want to do that expensive hardware refresh on storage. So those are the situations where you can continue to have your applications or user shares in your data center. However, you can actually store the data in AWS. And we can also help you reduce latency with the following use cases. So thousands of customers are already using Storage Gateway, and here are some of the use cases why they started using Storage Gateway. Okay, so the first one is, imagine that you have lots and lots of database servers on premises. Oracle, you're doing RMAN backups or dumps to some network share on a NAS storage, or to a deduplication device that's very, very expensive. So many of our customers actually do their database dumps or backups to an Amazon S3 file gateway. What it does is S3 file gateway can expose either an NFS or an SMB share, and so that you can store the files into this network share. And in the background, S3 file gateway will push the data to S3 and or Glacier or Deep Archive and reduce your storage costs. Right? On premises, it will maintain a local cache that you can allocate and specify how much, so that it has a hot data cache locally, so that hot data can be accessed with minimum latency. So that's one use case, one example of where an S3 file gateway can be used. Of course, you can also use this to store all types of various files and video files or audio files or whatever is the use case. The second is, lots and lots of customers have already replaced tapes, and some of them are continuing to replace their tapes using the Tape Gateway product. Essentially, what Tape Gateway does is it emulates a virtual tape library, so that the backup software thinks that it's writing to a tape library, but in the back, what's happening is it's writing to the Tape Gateway, which in turn is sending the data to S3. And when the backup software ejects the tape, the data is moved from S3 to Glacier or Deep Archive, and further reduces your costs. Now, this is an example of a backup software, but since today's topic is network attached storage, if you have NAS storage, which is using NDMP to write to tape libraries, you could actually replace that physical tape library with Tape Gateway, so that your NAS storage is using NDMP to write to AWS Tape Gateway, which in the background is storing the data in S3 or Glacier. Okay, so that's another use case. The next use case, which Alan just covered around, is FSx File Gateway. If you have hundreds of users on premises who need home directories, you can replace your existing NAS storage with an FSx File Gateway, so that it exposes local hot cache with low latency, and in the background, the rest of the data is stored in FSx for Windows. You can choose to use either over the network, public network VPN, or you can have a direct connect between the two data centers and further reduce your latency every time the data has to be fetched from AWS. But remember, all these gateway products have a local cache, so we are already reducing your latency for hot data. And last but not the least is we also have a volume gateway, which exposes iSCSI block volumes. So you could have a database server or a virtual machine or any application that actually stores video content or any other content for that matter on a block storage. For whatever reason, if the application has a limitation that it has to use block storage and not a file storage, then you can use a volume gateway. And in the back, it also maintains a local cache. And behind the scenes in the background, it stores the data in S3. You could actually also take snapshots of the volume gateway, and those snapshots are stored as native EBS snapshots in S3. So eventually, you could also use those snapshots to recover in AWS as native EC2 instances. So that's an added benefit of using a volume gateway. So I talked a lot about these various types of gateways and the various use cases that you should consider. The reason why we came up with this is really because of those tens of thousands of customers who were in the journey and identified that, okay, I can migrate a lot of my applications to AWS, but for some applications, I still need to stay in my data center, but I want to use AWS storage. For that use case, these gateway products are perfect. So with that, I will pass it back to Alan for a short demo. Let me stop sharing. Alan, it's all yours.
Good. Just sharing out again and getting my lab environment back up. So hopefully you can confirm if you're still hearing me and that you're seeing AWS Storage Gateway in my AWS console?
Yes and yes.
Great. So with AWS Gateway, as Chandra was talking about, we definitely have the ability for multiple options. In this particular tab, I'm going to just spend a second here to show that I've actually have two running in this particular region, Ohio, which is actually a tape gateway, which I was doing some testing with out of scope of this webinar, doing some testing for a customer. And then the FSx File gateway that you saw in my previous demo, you actually saw me use it, but you didn't see the actual workings behind the scenes. And this is where we could see how we're able to connect that FSx gateway to the file system behind it. And even shows out a recommended sort of UNC map, either map a drive or UNC path to the share. That's what I had a drive mapping to, sorry, a UNC path to in the earlier part. But for now, I wanted to focus more on our S3 file gateway that I have deployed here in the Oregon region, where the file gateway is configured with, in this case, an SMB share. But that SMB share is front-ending a S3 location. And I can actually show you that S3 location that when I go into this particular bucket and this prefix, I have a couple of files, some AWS region JPEG files. And what this looks like to the customer when actually sort of accessing that path from the UNC path, it's in this case I've got a drive mapped S for SMB, and here are those two files. So as we're looking at the gateway from the UNC path, and this would look very similar if it was a NFS export and I had a Linux client mounting to that, I would do an LS and see those files. And as I look at this and potentially manipulate files here, and I'm just going to do a very simple copy and paste to generate an additional file. See, the file has been generated here, so now that gateway is uploading that to S3 in the back end as quick as the network is going to allow us to. So if I come back to look at my S3 view of this, I can do a refresh of my objects, and we can see there already that new object has been uploaded. One of the use cases here, over and above where we used to use this for group shares and home shares as well, FSx Gateway is going to probably pick up that workload. But we still have applications that are maybe not fully moved to AWS yet, where a component of that is running on premises and needs a SMB share or NFS share, needs to get data into S3, where the other part of the application maybe already is built cloud native in AWS that would like to see and do its analytics on objects inside of the S3 bucket. So now we have a very user-friendly, application-friendly way of being able to be, file system-like on premises with SMB or NFS, and those objects are now accessible in region for the analytic type of applications to access them. And we could even update and create new files here, and through a cache refresh, those would show up back at the file system on premises. So, it definitely gives us that hybrid interaction for cloud applications as you're moving them into AWS. It doesn't have to be an all-in-one, instant everything in AWS. So that's what I had prepared. Chandra, I'm going to hand back to you unless there's a specific question that the screen may help us answer.
No, this was good. Thank you, Alan. That was a great demo. And as Alan pointed out, each one of the file system, AWS native file systems that we talked about today has a purpose. If you're ready to migrate your NAS into AWS, you have choices: Elastic File System for your Linux workloads, FSx for Windows File Server for your Windows workloads. And Storage Gateway is a great, has another, a bunch of solutions as part of Storage Gateway. Depending on your use case, you can start leveraging Storage Gateway right now in your data center. Start using AWS storage. You keep your applications and users on premises. And more importantly, the data that is landing in AWS S3 or FSx for Windows via the Storage Gateway can also be used for along with other AWS services. Many of our customers use S3 File Gateway as an example to get the data into Amazon S3, and then later on they use their AI/ML services with the data that is stored in S3. Benefits of these architectures, the file systems available in AWS, is you eliminate your expensive hardware refresh costs, right? Pretty much all of these offer pay-as-you-go model, eliminate operational burden. These are all fully managed services from AWS. Your data is still yours. We just shifted the burden from you to AWS. Increase agility because you can access the data and marry it with other services in AWS and accelerate your innovation. And and another important thing is you could actually generate data on premises, get the data into S3, for example, or FSx. You could generate, another application might be able to generate data in the same S3 bucket, and you can make the data visible on premises as well. So it's both directions, actually, in terms of making the data visible. As a next step, we'll definitely walk through the Q&A, some of the questions that we have not answered so far. But talk to your AWS account team. If you want to deep dive on any of these use cases or services, ask for hands-on immersion days. And of course, if you want to do a POC, ask your AWS account team for POC assistance, and we will be happy to help. And there are 3 more webinars, such webinars like today, that are going to happen. The next one is data protection for applications that are already running in AWS. What's Lakehouse architecture and why it matters, and hybrid cloud disaster recovery in AWS.